Ladies and gentlemen, welcome. And looking around the room, I'm looking for that common theme as to those of you who've decided on a Sunday afternoon that the power of poo is something that you want to come and enjoy. And I'm really glad you've come to join us, because I've been looking forward to this all week, and I've been telling everybody, because it's just so good a thing to say, isn't it? What are you doing on Sunday? Oh, I'm going to the power of poo. And this is all part of York's Festival of Ideas. And the University of York have been doing this with the theme of the power of, and it brings together a range of world-class speakers, as you know, and I'm thrilled to have these four with me this afternoon, and I'll introduce them to you in a moment. Exhibitions and performances all over the city of York. And if you want to know any more about it, do look on the website for more about the Festival of Ideas. But we're here today to talk about poo. And it's one of those things that it can be a real problem, and it can also be a huge opportunity. And I hope today that we can give you that balance of problem and opportunity. But just to give you an idea, 67 million people in the UK today. On average, the average person poos about 145 kilos a year. So do the maths, that's about 10 million tonnes of poo from people in Britain. Now, contrast that with a cow, a dairy cow. And a dairy cow is, on average, when they get to the peak of their performance, about 62 kilos of poo a day. A day. And there are 2 million, well 1.8 million, call it 2 for the maths, of cows in the UK. Dairy cows, there are other cows as well as dairy cows. That's 40 million tonnes of dairy cow poo a year. So just keep those numbers in your head. 10 million tonnes, 40 million tonnes. Wow. Imagine that. And imagine if you could do something with it. And that's what we're going to talk to you about this afternoon. So there's plenty of it. I'm going to shed some light on who's with me. We've got people from our Bio Yorkshire partners. Bio Yorkshire, I chair the Industrial Advisory Group. My name's Steve Bagshaw. And Bio Yorkshire brings together institutions from York, that is, University of York, Ferro Sciences, Askham Bryan, the Biorenewables Development Centre, and also industry. And together what we're trying to do is to create a new green economy in North Yorkshire, and in York and North Yorkshire, and try and create jobs and economic growth based on bioeconomy. One of those is the resources that you use to start with, so the feedstocks. Who is a feedstock in this case? And we look at all sorts of different feedstocks in the bioeconomy. Anything that you can make healthcare products, food, fuel, chemicals and materials out of. So traditionally you bring all of those together and you create what's called the bioeconomy. And so what I've got this afternoon is with you to share with you is someone from Yorkshire Water. He knows a lot about poo. I've got someone from Flamingo Land. He knows a lot about poo, but different poo to Yorkshire Water. I've got someone from the University of York who is an expert in dealing with poo. And I've got someone from the Biorenewables Development Centre who's also really good at dealing with poo. So between the four of them, we ought to have a ball. I'm going to get them to do their bit, and then we're going to leave plenty of time for you to ask those difficult questions. But I've given you some starters of what you can do with it. Wow. Okay, so where have we got to? Let's start by introducing the first of our panellists, Professor James Chong. Now, Professor James Chong is from the University of York. He's a team leader, a theme co-lead and director in water, waste and food in the Department of Biology. Now, he started as a microbiologist in Manchester, did a bachelor's in that. He then went on to do work with the cancer research, so it's a different kind of bioprocessing, methodology. He then went to America, to Cold Spring Harbor Laboratories, and then came back to the University of Bath. Came to the University of York 20 years ago and started on a journey to become one of the country's leading experts. And I'm going to say this slowly because you'll like every word of it. He is a microbial community, that's bugs to you and me, and the community of bugs, dynamics of an anaerobic digestion. So he's a leading expert in the field of microbial community dynamics and anaerobic digestion. Now, if any of those 5 words don't mean anything to you yet, they will any moment now. He works with Yorkshire Water, he works with other water companies and other commercial users of anaerobic digestion, and is in the business of optimising resource recovery from organic wastes such as sewage. So he's quite the expert in poo. James, what on earth is anaerobic digestion?
Thanks, Steve. Okay, so anaerobic digestion, I think, is ancient recycling. So what we're trying to do here is recover resources from waste. We're going to talk mainly about poo today, but actually anaerobic digestion works on any kind of organic wastes. So that's anything that has been made by a plant, might have been eaten by an animal, and there are resources there that we can recover. So typically when you carry out anaerobic digestion, you get back carbon in the form of what we now call renewable natural gas. So this is a drop-in replacement for the stuff you dig out of the ground. So you can use it for cooking and heating and everything like that. And you also get a nitrogen-rich digestate, which can be used as fertilizer. So it's normally spread on fields as a way of growing plants. Anaerobic digestion, as you mentioned, is a biological process that is run by groups of microorganisms. So we think, somewhere between 500 and 1,000 different sorts of microorganisms working together in these communities to break down that organic material so that we can recover resources. And we've got a slide so I can show you sort of anaerobic digestion in the field, as it were, but actually in a lake. Okay, so maybe we can get this to play. Don't try this at home. If you walk around in the lake, you'll see you can collect bubbles, and then you can get a volunteer, in this case my son, to set fire to those bubbles. Okay, so that's the renewable natural gas being made by this group of organisms. The important thing about anaerobic digestion that I've completely forgotten to mention is it's anaerobic. So that means in the absence of air, more strictly in the absence of oxygen. Okay, these organisms only work when there's no oxygen around, and actually some of them are very, very sensitive to oxygen, and they'll die if there's more than 10 parts per million oxygen near them. So this is why I say it's ancient, because when the planet was first formed 5-6 billion years ago, there wasn't any oxygen in the atmosphere, and these were some of the first organisms to evolve to kind of survive under those circumstances.
So you've said there, maybe you could just take us back slowly, because that was pretty impressive. You managed to set something on fire. Perhaps you could just tell us again, how does that work then? So you've got some sort of sludge number, and is it full of the organisms you're talking about?
Okay, so if we think about what's in the lake. So typically, this is the University of York Lake, so you're going to get plant matter blowing into the lake and gradually falling to the bottom. So that's mainly leaves, twigs. We have a lot of waterfowl around, so they're pooing into the lake. We have students dropping bits of sandwich in the lake. So all of that organic matter settles, and then down there are going to be microorganisms that think this is lunch. And so they can break down all those materials. So we're starting with long bits of biology, so DNA molecules and fats and carbohydrates. And those microorganisms can break them down. But they're all quite specialized. So you'll have one organism doing one particular reaction and then spitting out the rest, but that will give them enough energy to live. And so you have these different layers of organisms that are breaking down the material into food that they can eat, so they can make more microorganisms. And at the very bottom, there's a group of organisms called methanogens that make methane, which is what you saw being set fire to.
Right. And so you've talked about the process of anaerobic digestion. What's the benefit to us, though? I mean, it was very impressive that you managed to set something on fire, but why is that helpful or useful to us?
Yeah, so as you mentioned at the beginning, Steve, there's 10 million tons a year of human poo being generated. Now, that's a really large amount to try and visualize. You know, if you think about the fact that the main tower on York Minster, that's about 50,000 tons of stone. Okay, we're looking at 10 million tons of poo. That's a really big pile of poo. And obviously, you don't see that, so it's going somewhere. So one of the big benefits of anaerobic digestion is reducing that volume, breaking that material down, and we get the additional benefit of turning it into something that we can use. So the main thing is this gas, and because, like I say, it's essentially the same as natural gas, typically what happens when the water companies are processing this is they use it in a combined heat and power plant, so they make electricity and heat, and obviously the electricity can go into the grid or be used as part of the water processing requirements. So yeah, we're recovering energy, and then we also end up with nitrogen in a form that can be used as fertiliser.
That's cool. So when we get to Yorkshire Water, I'm going to, as a headline, I'm going to ask you how you do what James has just said, because obviously, as he said, the poo is not inside. You flush the chain and away it goes. Who has a chain anymore? But you know what I mean. You flush the toilet and it goes down and disappears, and we never see it again, hopefully, and it just disappears. But obviously, Yorkshire Water do something with it. What's your interest as a researcher, though?
Okay, so anaerobic digestion, like I said, has been around for a really long time. And although people have worked out how to use it, the simplest form of anaerobic digestion is to dig a hole in the ground, put your waste in it, whatever that is, if it's poo or anything else, cover it over with a lid, and then collect the gas that bubbles off. Now, when we're dealing with 10 million tonnes a year, just digging a hole in the ground isn't good enough. It needs to be going through a process that is as efficient as possible. And that's been really optimised by engineers, so we really are very good at mixing poo and moving it around, but no one's really looked at the microbiology. And as I said, we think there are anywhere between 500 and 1,000 different sorts of organism there, but most of them aren't contributing to making gas. Most of them are there because there's a free lunch to be had and they want to make more microbes. And so we're really interested in how we can optimise this process. And there are big challenges with that because there aren't very many levers you can pull when you're dealing with 10 million tonnes of poo. You know, you can't change the pH, it's too expensive. Mm-hmm. So there are a few things that you can do, like change the temperature, although again, that gets expensive if you want to make your poo really hot. Or we can stir it differently. And so the question is whether we can change the biology in a way that makes this process faster and more efficient, so places like Yorkshire Water don't have to build more sewage works, because one of the problems is as the UK population grows, so does the pile of poo. So, you know, our big challenge here is whether we can put more material through the same assets in a fixed time.
Right, so productivity of what the assets that we already have is what is driving you. Yeah. That's brilliant. James, we'll come back to James, and if you think you've got your questions, have you? You're thinking of what you're going to ask, because that's a really good start. Let's go to Martin from Yorkshire Water. So Martin's the Innovation Partnerships and Portfolio Manager at Yorkshire Water, and has worked across a whole range of sectors in his career. And the last 25 years he's been in change management and innovative solutions, complex problems, and now he's in his second stint at Yorkshire Water, delivering innovation that spans the full water cycle, which I'll ask him to just explain what he means by that. But he's helping to deliver a thriving Yorkshire, right for customers and right for the environment. And he sits on our Industrial Advisory Group and on the Future Humber Advisory Board. And he's also a national champion of initiatives to deliver value and equity for customers across the water and wastewater sector. Martin, where does Yorkshire Water start with the human waste that's produced? What sort of quantities are we talking about? What sort of, what are the issues in collecting the sewage of Yorkshire?
Yeah, cheers, Steve. I'll start with quantity. So let's look at Yorkshire as a whole. Obviously, Yorkshire Water serves the whole of Yorkshire, and that's 5.5 million people. So that's the maths from before. I'll go into some of that in a second, and 140,000 businesses. So it's a big footprint, and it's a lot of poo. And to put numbers on it, it's 1.3 billion litres of wastewater. Now, I call it wastewater. There is more than just poo, and actually when we talk about the potential opportunity, there's greater opportunity, but it's also greater problems as well. And I think that's about 2,000 tonnes of poo a day if you were to equate it to poo. So that's a lot. manage a number of assets. I think James talked about assets. We have over 600 sewage treatment works, which is ultimately the location that the sewers arrive at, and that the multiple processes there look at. I mean, the ultimate purpose of the sewage treatment works is to return effluent to the environment, be part of that water cycle to a certain quality level. So we do that at 600 sewage treatment works, and that connecting to people's homes. We've got 30,000 miles, or over 30,000 miles of sewers, and that's quite a significant mileage. That would take us from York to Sydney and back in sewerage.
Okay.
You wouldn't travel that way.
And that's a great description, isn't it? Just before we get into the kinds of things that you're doing with that are positive, what kind of things end up in the sewers?
Oh, where do we start? Where do we end? So we do have problems with what ends up in the sewers, and 40% of the blockages that are kind of arrive or occur in sewers are created by things that shouldn't be there. And I've got a little experiment it works on one level of showing a blockage issue, but it also talks about recovery, which I think could work.
Okay.
But I do need 2 volunteers for this.
Oh.
Young volunteers, I think, would be
Do we
best.
have any volunteers?
We've got any volunteers?
Oh.
It doesn't matter at all. I'm looking for anyone who's willing.
I've got a lady
Okay.
at the back here.
Lady at the back and young lady at the front.
Okay.
Who I will suggest is a plant, and she is my daughter. However, we will see what we can do here. So if we hold that for me for a second. Okay, what we've got is 2 bottles of water. Pretty straightforward. And then we've got 2 things. One is a piece of tissue paper, and one is a wet wipe. So, who wants the wet wipe and who wants the tissue paper?
I'll go wet wipe.
You go wet wipe, you go tissue paper. So whilst I pass that to you, if you can ask your mummy, this lady here, pop the tissue in. You pass that along, and if you can pop the wet wipe in. And once it's in, I'm just going to ask you to do a bit of a cocktail Tom Cruise moment for those that of a certain age may get that. Do a shaky, shaky, shake, as if you're making a cocktail, but make sure the lid's on properly. Probably should say that first.
Sorry, it's just the legs that get wet.
Give it a shake for 30 seconds. Keep going, keep going. You got the cocktail making perfect up there, haven't you? Okay. So if you can hold up the bottle. So we've got at the back the wet wipe, which is bubbly. So you've got some of the ingredients from the wet wipe that create bubbles, but the actual wet wipe is still intact. So it doesn't break down in water. And at the front we've got the tissue paper, which has broken down. Although you can still see it, you settle at the bottom, but it's broken down in essence. So why is that important? On one basis, the wet wipes shouldn't go down the sewers because perfect example, you picked that out.
Thank you.
That will not break down no matter how much shaking and other processing goes on. And when that comes to a works, it's an issue because it needs to be filtered out of the process for sludge, but also the biggest problem there is what it does to the sewer pipes. The toilet paper is a good example because what you've got there is that should go down the sewers. It's designed to go down the sewers. So there's three things that should go down the sewers, and they're the 3 Ps, and that is poop, pee, and paper. The paper breaks down, and what some countries are looking at is actually how throughout the whole process you recover, and that's what a lot of this is about recovery. You recover cellulose, which is one of the key ingredients in paper. So in the Netherlands, they've got cellulose recovery plants where they recover that source ingredient and put it back into production. So make that circularity. So that nutrient and poo, wee and paper, it's just a mass of nutrients and positive nutrients. There's some baddies in there, and the sewage treatment work process is about getting rid of the baddies, but it's also about recovery of them. But a bit more audience participation. We've talked about some things that should end up in the sewers and some things that shouldn't. What's the strangest things you think has ended up in a sewer? I'll ask somewhere else because I've been practicing this, and I think the plant might be overreaching. False teeth, lots of false teeth. Lots of false teeth in the sewers.
I've had friends putting goldfish down the toilets.
Dead ones? Was that the friend? Okay. Well, the goldfish won't be. Goldfish? Anything stranger? Anything bigger? Alligators, quite often in tropical countries, live in sewers. Yes. Yeah, I'd say we get phones. Think bigger. What's the biggest thing?
Go on.
Yeah. Bricks. Some sewers are made of bricks, and sometimes if a sewer collapses, the bricks do end up in the sewers. But actually, sometimes things are dropped in there, paint, etc. Yes. Half a car. That's quite a specific example, but yeah, half a car. I don't know how you got that one. Half of a Mini has been found in a sewer in London. I'm not sure where the other half went. Toys, yep. Specifically, any? Poe from Teletubbies? Toy, Buzz Lightyear? Lego, lots of Lego. Suitcases?
Rats.
Rats in sewers are an occupational hazard. Yeah. Shoes, yeah. A sofa, yes. No more from you. Lots of good examples. Now, most of those, the bigger items, don't get flushed down the toilet. But a lot of those are kind of rare one-offs. But the main things that cause blockages and create issues for us to be able to run the process sufficiently are wet wipes, fats, oils and greases from cooking, and nappies.
And how do you deal with all this then? So I'm imagining a sewage works. Mm-hmm. You've got all this different stuff coming down the pipe towards it. Can you just give us a quick how it works?
Okay, so for every sewage treatment it's different, but the base model is kind of core. There's normally a minimum of 2 treatment processes. And James is probably more the expert in the secondary part, which is anaerobic digestion. But generally, you'll find a filter capacity at the front end of a works. That could just be a mechanical filter or a biological filter. And that looks at removal of the kind of key negative ingredients within sewerage, and then we look to optimise the product through different forms of treatment. We use kind of filter beds, which has filter media, live media, biology, or we can use things like UV light as a kind of a tertiary kind of level of treatment, which can, each environment will have a standard that the effluent needs to return into the watercourse or the sea, and the treatment processes are developed based on that requirement.
Right. And can you give us the noddy guide to why Yorkshire Water gets in the news? Sewage is a big issue, isn't it? But maybe the noddy guide. So just the 30 seconds to a minute answer, not the 10-minute answer.
The major reason people see Yorkshire Water in the news of now is that the sewage doesn't end up where it should end up. Mm. It should end up following the route from homes to pipes to sewage treatment works to treated to out. But a lot of the focus at the minute will be on outfalls, combined sewer outfalls, and I know there's a lot of media attention, rightfully so, and there's a lot of investment. And that, in essence, is a part of the design system to avoid customers' properties backing up with sewerage, which is a horrible experience. That at times of overcapacity, the sewage is diluted with what we call surface water and ran through an outfall into the environment. If that works as it should do, the dilution should be enough to make sure that damage to the watercourse is minimum. But I think one of the challenges is how do you make sure that is the case and it's not failing when it shouldn't be failing. Yeah,
brilliant. Okay, thanks. Opportunity for questions later if you want to ask and go further on that. But that's brilliant, Martin. Thank you for that. Let's change tack completely. Let's talk about zoo poo. So Kieran is from Flamingo Land, and he is the Science and Conservation Officer at the Flamingo Land Resort. He's working there and oversees the research undertaken on site, leads on native species conservation projects, also holds a voluntary position of sustainability officer there. He is a zoologist by training from Swansea and has an MSc in conservation ecology from Oxford Brookes, and has previously worked as an animal technician and spent time training and working on a conservation and on reserve in Botswana. Wow. How wonderful to have you here, Kieran. Now, tell us a bit about the zoo at Flamingo Land.
So, it's pretty different from what we've been speaking about just now. There's I always think when I do talks at the zoo that I talk in big numbers about poo, and then you hear million tons and billion tons. So this might actually seem smaller than I thought it would. But Flamingo Land is home to over 110 different species of animal, from the ones that you probably come to see, the big ones, your hippos, your rhinos, your lions, to the tiny, tiny ones like giant African land snails, stick insects, other small invertebrates. All of them poo, and that's probably one thing we'll get onto. It totals over 1,000 species. We do a count up every year. We say over 1,000, not species, individuals. A lot of them are stick insects. We haven't got 1,000 rhinos walking around the zoo or anything like that, but they all live their home there as part of a bigger project. What I see as conservation, they are important ambassadors for their wild counterparts, most of which are suffering from issues facing them in the wild, and either we're part of a breeding program which can lead to releases in the wild, or we're part of what we like to call a safety blanket for some species that either isn't suffering right now, or they haven't got the capabilities in the wild to be released. I always talk about Sumatran tigers. There's actually another one, there's an addax, which is an antelope, my favourite antelope in the zoo. It's found in the Sahara. There are more people here in this room today than there are in the wild of this species. And so that threat, unfortunately, which is causing them is hunting, is not gone. So we look after them, we breed them, and then we hope that in the future, when that threat's gone, we can have that population that's healthy to get them out in the wild. But while they're in captivity, we look after them. Not myself, an expert team of keepers look after them, feed them, care for them, make sure they're all healthy, and of course, clean up the poo. In the zoo as well, I will just say we use poo as a different aspect at the moment. So I love talking about poo, not in the waste sense, but in terms of what animals use it for, and how you can see diets and behaviours inside of poo. There are some pictures, actually. In terms of the size of poo, it starts off with, that is a white rhino poo. On the right, you can see a nice big nugget there. And full of grass. So a white rhino is a grazer, eats loads and loads of grass. They've got quite a good digestive system. So actually, one of those wheelbarrows is a third of what we clean up from one of our rhinos a day. So when I was talking about numbers, it's over 60 kilograms a day per rhino. But when you're talking about 2,000 tons a day, I was like, oh, actually, that's not that much. But there are more pictures. You've got some primate species like lemurs. They always look kind of a bit too human to me. I didn't include baboons because they do just look like small human poos, to tiny guinea pig poos, and there's more. I've got lots of pictures of poo. Giraffes poo, that one for our keepers, it's really interesting when I talk about it because giraffes are incredibly good digesters, and so thanks to that they have tiny poos for the amount they eat and everything, but because they poo from such a height, those little nuggets do bounce about, and so clean them up and find them all can be a bit of an issue for the keepers. They use a big rake, and I think there are a few more. And that is what we'll probably get onto in a bit. That is what we call our midden. So I'm sure we'll talk about it in a bit, Steve. But we don't sell our waste. We collect it every day. The leftover straw, hay, and feces. Collect them in the wheelbarrows, take it down to what we call our midden, and it gets piled up there into a bigger and bigger. If I should have got someone to stand next to it, because that is probably the height of two people right there. It's quite far away, and it's probably about 15 metres long. I don't know how deep. I didn't wade into it. I'm sorry, but that gets piled up, and then we ourselves at the moment, all we do is use it as fertiliser on some of our fields. So we spray it, or we not spray it. We collect it and tip it over our fields to try and increase the health of our fields that we then can cut and use as hay and feed in more of a circular environment, which I'm sure people from Bagshaw will appreciate. But yeah, so I think there are more pictures of poo. Carnivore ones are slightly different. So that's a lion on the right and a cheetah on the left. We don't actually spread that. Same as our primate poo. That gets put in bin bags and burnt just because of the risk and chemicals that carnivores can carry in their feces. It's not sort of as clean, shall we say, as a herbivore, and then I'm sure I'll talk about this in a bit, I'm sure. And then Dik-dik poo, I included that not for the name, because I'm sure some people laugh at that, but actually dik-diks are a very, very small antelope in Africa, and I said to have the driest poo because they suck all the moisture out. They're very, very good at retaining water, so that poo is so dry. And they create little midden piles or circles, and they use that sort of like as a territory display. And that's one of the things we like to talk about, is what they use for territory or indicators and scent. There are otters that will lay their feces in an area, and you can actually tell if they're lactating or not. So a female can basically, because of everything that goes through them, the animals can smell those lactates in there and say, okay, well, she's fertile or she's not fertile, she's got young, and so those males might ignore her, bother her, and that will be through loads of different animals. There's so much that we can't smell. I don't actually sniff my poo, and I've never tested it, but I'm sure if I tried, I wouldn't be able to smell if someone was lactating or not from that. But yeah, so there is loads of it. And then to finish off, a black rhino poo. So the opposite species of rhino we have here. I'm not sure if you could see from the start. I should have put them next to each other. But they are browsers, so they eat mostly foliage and leaves. And so actually, when you look at the amount of grass in there, there's a lot less there because they have a different sort of content and they break down and they eat in a different style, live in a different style, still produce huge amounts. And there's one last picture, which is another wheelbarrow full of poo. So they do that as well.
Kieran, I mean, it's absolutely fascinating seeing what you can tell from the poo, that you've shown the different types of feces of each of the different types of animals. Are there any restrictions on you as to what you can do legally with this stuff?
There are, yes. And from England, I'll say that right now, we haven't tapped into the full extent of what we probably can do with this. For ease over the years, we have sort of gone with the fertiliser route, just because there are things called ABPs, animal byproducts, which are a government ruling. You can have level 1, 2 or 3. Almost every one of our animals or species falls into level 1 or 2, which then reduces what you can do with that feces. We've been told that we cannot use it as a commercial asset, so that was in the past, so again, we've not looked into it recently, but that would mean that we can't sell it as an off product. So it goes on the midden, but then there are other zoos that have started tapping into what they can do internally. So they have looked at, can you power a hippo house? And that's the electricity needed to power the lights, the temperature, the water, heat. Can you power that with a hippo's poo? Yeah. So every enclosure we've started looking at in new enclosures, we've had that conversation of what sustainable measures can we do? And it's never fully formed into the geothermal or the biorenewable sort of side of things in terms of using their own feces to heat themselves. Sometimes that's due to the amount you might need for the whole year that we might not be able to produce from 1 or 2 hippos. Right. Or it might be the opposite side of things and you say, actually, we're still going to have to waste it, or you need an extra thing. Marwell Zoo have done one for one of their houses, and they have used the straw and the hay, and they turn it into nuggets that they burn. But it's not just the feces. So there's lots that you can do, but we do have restrictions on us into what we can do. Working with Bio Yorkshire recently, it's really sort of opened our eyes to the possibilities of what there is out there for us to do with, and I'm sure other zoos around the country will also be doing the same.
That's brilliant. I wonder if we should let Anna just say a little bit from what you can do with poo and the different aspects of it. So that's brilliant, Kieran. Again, I hope you're thinking of your questions, because if you want to see any of those slides again, if you're thinking, I'd really like to see whatever poo it was you really have your eye on, then we can do that for you. It's that sort of a show, this. So Anna Alessi is a Project and Communications Manager at the Biorenewables Development Centre, project manager there. And this centre is just across the road here at Dunnington in the University of York. She manages a diverse range of projects in collaboration with academia, industry and local farmers, both locally and nationally. The projects explore novel food production systems, manufacture of bio-based products and the production of bioenergy. She is also a microbiologist, so you can see a theme here, and she's previously worked here as a postdoc researcher in the University of York's Department of Biology, I believe, with James, actually. So there we go. And during her time, she's contributed to several large multidisciplinary collaborative projects working on something we've heard James talk about, which is the analysing of complex microbial communities in anaerobic digestion, just to say it again. There you go. Today, she's going to help us understand a bit more about the gases that animal poo creates, and why that's an opportunity, which is where the connection is also with Kieran. But first, could you tell us, Anna, a little bit about the Biorenewables Development Centre and how you measure the power of poo?
Okay, thank you, Steve. My name is Anna, and I work at the Biorenewables Development Centre. So we are a research centre at the University of York, as Steve said. And what we do mainly, we work with the industry and the academic partners on different projects that are looking at how to use natural and biological resources instead of fossil resources to produce green energy in the form of bioenergy or more sustainable products, chemicals and materials. And one of the things that we do at the BDC quite often is to use animal waste, so animal poo, to produce energy in form of the biogas during the anaerobic digestion that James mentioned. So obviously the anaerobic digestion happens, let's say, on the farms very often, run by farmers on a very, very large scale. So for example, you can see a tank, which is a very well sealed tank because the process has to happen without the oxygen. So this tank on the farm is 2 million liters of animal waste, which is pretty much equivalent to Olympic-sized swimming pool. So at the BDC, we don't have facilities big enough to work at such a big scale. So what we do, we scale down the process to mini reactors, lab-scale reactors, that are basically like a size of pint of milk. So you can see on the picture my colleague, Alex. At the moment, she's assembling those 80 reactors. And what she does afterwards, she does some kind of analysis to measure the biogas that is produced at the end of the process. So what we try to understand by doing this type of research is which animal waste will produce most biogas, how we can use novel and more innovative technologies to actually increase the production of biogas. So the more biogas is produced, more energy can be recovered, more electricity and heat can be used by the local communities. And the other thing that we do as well in the center is to use this end product that I think James mentioned called digestate. So this is the kind of end product of anaerobic digestion, which is nutrient-rich, can be used as a fertilizer. And what we do, we try to identify which digestate might be better for plants. So we measure the plant growth, we look at the plant health, and how this organic material can be used on farms instead of artificial fertilizer. So that's our work at the BDC.
And what are the kinds of animal poo you work with there?
If we go to the next slide, I just want to say, obviously, the volumes that we are dealing with in North Yorkshire are quite big. So there are 10 million animals, farm animals, across North Yorkshire. 1.4 million tons of muck is produced annually by animals in North Yorkshire. So at the centre, we've been dealing with all sorts of poo. Unfortunately, we haven't dealt yet with any kind of exotic animals, but on-farm animals such as pigs, cows, sheep, horses, goats. We had a number of projects using chicken manures, or also recently fish. But one of my favorite, if you move to the next, it's panda poo. So this is my favorite poo only because when I was a student in Aberdeen back in 2011, I had the chance to work with panda poo. So at that time, Edinburgh Zoo received a gift, a loan, let's say, of 2 giant pandas. And the institute that I was based at was asked to analyze the pandas poo. So Kieran probably knows a lot about pandas and the digestive system, but pandas, they are vegetarian. They eat bamboo, mainly shoots and leaves and stem, but the digestive system is typical to the carnivore animal. So they are not very well evolved to digest such a difficult material. They have to eat a lot and pretty much constantly, up to 16 hours they spend on feeding on bamboo. They leave a lot of mess, so a lot of waste, but also because of the digestive system that is not very well evolved, most of that material ends up in the poo. So I think there's a picture of the poo. There you go. So yes, so the kind of a green, I think they call them green poo balls or things like that. So, so that's what's happened when a panda eats the bamboo. But that's one of my favorite
That's great.
waste.
And if you thought you were coming to something sensible this afternoon, we've now got to the favourite poo
Yes.
test. But which of these poos is the most exciting from an energy generation point of view?
Okay, so like I said, well, I think Kieran as well mentioned it, that obviously different animals will have different diets. That will have an impact on the poo that they produce, the quality, and obviously the quantity. So the smaller animals will produce less poo, bigger animals will produce more poo. So if we move to the next slide. So we have those 3 common farm animals, and the waste from those animals are mainly used in anaerobic digestion on farms. So, example, the pig is an omnivore animal, so basically the diet is very similar to ours, so they can eat a wide range of foods. They will produce around 4 kilograms of poo per day. Then we have a chicken. Chicken is a bird, so they have a different digestive system, and they produce much smaller amounts of poo, around 100 grams per day. And then we have the most common one, which is a cow. Cows, obviously, they are quite large. They are grazing animals, so they will feed on grasses and other plants. Again, very difficult material to digest. But in contrast to panda, they actually evolved a specialized digestive system that kind of helped them to digest this vegetation. They obviously contain this very famous 4-chamber stomach. And they will produce, well, depending, I think you mentioned 50, 60 kilograms. Mm-hmm. It depends on, on the animal age and how they are, housed. Around 50 kilograms of poo per day. So I just have a quick question about actually energy that we can recover from the animal waste. Well, I'll ask you a very simple question. So which animal waste do you think will produce most energy? Would it be a cow poo? If you think it's a cow, just raise your hand. Okay.
Okay. Well,
all right.
Okay, yeah.
What about pig?
Oh,
maybe
pigs.
favorite.
Oh,
Yeah.
A lot of pigs.
Yeah. What about chicken?
Oh, chicken and.
Okay, so kind of, I think probably pig wins when it comes to, but actually you're right. So yes, chicken will produce most energy per ton of the material. That will followed by a pig material, and then cow. So if we do the click, yeah. So the most will be recovered from the chicken waste, followed by the pig and the cow. And the reason behind that is really that the cows are the ruminants, as I mentioned. They are very effective in digesting the food they eat. So all the energy will be basically used by the animal. And the stomach that I just mentioned is very similar to anaerobic digestion reactor. In fact, the microbes that are present in cow's stomach are very similar to the one that are present in an AD reactor. So that's why the cow will produce least energy per ton when it comes to anaerobic digestion.
And is that one of the, we're just making this up now, is that one of the reasons that people worry about cows? Because actually they've produced the gas before it becomes poo.
As mentioned, I think probably you've heard about burping cows and the impact the production of beef and so on will have on the environment, because the methane it will be emitted during the digestion.
Gotcha. Brilliant. So you were going to talk, I think, a little bit more about whether there were, well, have you got any other questions you wanted to ask the audience? I'm not sure that's it. Okay.
It. Yeah.
Well, we can move on. That's fantastic. Well, I wonder, so you've heard from the 4 people, give you 4 very different perspectives on poo. You've started with James giving you the basics of anaerobic digestion. You've got Martin telling you about the system that Yorkshire Water's using to try and cope with it and how it moves in and uses James's technology that he's a leading expert in as part of the system. James was talking about the productivity and how we're trying to improve the productivity. Martin was talking about how we deal with the fact there's settees and sofas and cars and stuff in there as well, and wet wipes as well. And how do you deal with the productivity when you're trying, first of all, to educate people not to put this stuff in their sewers? Then we went to Kieran and we talked a little bit about the variety that Flamingo Land has in terms of different poos. And Anna's brought us right back to home with the farm and how much gas we could produce from poo. So I hope that's given you a kind of yin and yang, if you like, of the opportunities and the problems that there are today. But what's it left you with as questions? Because coming into this, you must have had a ton of questions that you wanted to ask, and really obvious questions. So let's just fire straight in. We've got some microphones somewhere, but Surf here first, yeah. Yeah, just go for it. All right, no.
I mean, China's been growing plants from human sewage for years. What's your opinion of that?
Chinese sewage growth, James. Do you want to just say
They've
anything
been doing
about
this
that?
for years. Just wonder what you thought about it.
Yeah, I mean, so I guess the challenges that people think about and worry about in the UK is whether people are carrying pathogens, and so, yeah.
Some good points.
So absolutely, and this is one of the reasons that, you know, most people will tell you to wash your vegetables before, you know. So obviously, yeah, there's energy value there. There's probably more energy to be had by doing the digestion first. But yeah, I mean, essentially that's what we do in the UK as well. Post treatment in the UK, when we think the material is safe, it will get spread to fields. But there's very strict regulations about what time of year that can happen. Yeah.
It's around 60% of the end product. Yeah, about 60% goes into agriculture, currently used as a form of recycling.
Brilliant. Thanks for your question. Any more? Yes, at the back.
It's alright, I think I can speak louder. Compared to, let's say, like a pig or a cow or a chicken, where does human poo lie?
Oh, that's a really good question.
Can I return with a question?
Sure.
Maybe to the room. So it's not as productive as, say, chicken poo. So how many people's poo do you think it takes to power a light bulb? It's around.
Depends if it's a vegetarian.
Oh, I've gone with a mixed diet.
Because like I'm on iron tablets, obviously it's better.
Oh, that's a good one. Let's just go for some of me. I'm a meat eater, but relatively balanced diet. Not too much beer this weekend. Let's look. Well.
And is this across a day or like a week or like a year? Like
Continuous. If this number of people were continuously feeding into a production of electricity to a light bulb, how many would it keep up?
First, have a guess. 8. Anybody above 8?
Any 20,000 tonnes. That's a different answer. Hold on, darling. Ben?
I've been thinking 10.
You've been thinking 10. 10's not a million miles off. Any raises on 10?
12.
12. Keep going.
1,000?
No, less. We're going colder. We were warm over there. Not to go with a warm poo analogy, but
18.
18. We're almost there. Well, I'll probably get a little bit tedious now. 20.
20 people.
20 people to power a light bulb. And for example, one of our sewage treatment works, Nostrop, which is in Leeds, that produces enough electricity from poo to power 80,000 homes.
How many cows are taking?
Well, cows are much better at this.
Yeah, they would be better.
Yeah. So, oh no, probably half a cow.
Half a cow.
I guess. Yeah.
Don't Google that.
I think we want the back end. Any other questions? Who's going to take? Yes.
I was just wondering, you said that dictates have rights to
Yes.
two things. How do you actually measure the kind of like how dry, like what would be the scientific process of that? And follow up, which like moving across, what is like the if dictates are like the driest thing, what is the
the wettest. There we go.
Okay,
Yeah.
Kieran. I think we're in Kieran's wheel.
So in terms of how did they work out that the Dick was the driest, I wasn't there for it, but I imagine what they did was they would just sort of dry it, burn it, and see how much water was collected as they heated it. I'm looking at you, but yeah.
We measure something called TDS, which is total dry solid, and for digestion, it's better when we dewater and get as much of the water out of the process as possible. So it is measurable.
It is amazing what people are doing research on. So someone was in a lab doing that. But and then the wettest, it actually probably depends on the animal on the day and their diet and how their actual gut bacteria is doing. Because unfortunately, I showed the lion and the cheetah poo. If they've had some lean meat without any bone, that can make really, really loose feces. But if you have bad tummy ache sometimes yourself, that can change it. But I'm thinking about all through the different animals in our zoo now, what their poo looks like. I would probably go with, we've got cows, and they have quite wet poo compared to the pat to other solids. I keep saying nuggets, but I'd probably go with them. But there are animals that poo in the water, so tapir and hippos. That's probably quite wet once they've done it in the water. And then some of our rodent species like capybara and stuff would probably have quite wet as well.
Brilliant. At the back, Cash.
Hi. It's a question for Dr. Wolf.
Oh, there you go.
Thanks.
So, how I see poo, I see it more of as waste than as an opportunity. So I can't help thinking about waste. And it really brought it home when you talk about the problem with oils, because I'm one of the culprits that puts oil into the toilet. Yeah, and this is because I don't know.
Audience interaction. Boo.
And this is because I don't have an easy way, domestic way to dispose of the oil. I mean, I know that there is a big problem with the disposal of waste, and not just at the domestic level, but also at the business level, in terms of the regulations by the council and the charges and the taxes, yes, to dispose of waste. So what's the simplest way, please, to dispose of oils?
The simplest way. I guess ultimately with oils, it's easy to move and transport them when they're dry. One thing we promoted, it depends on volume, but it's to make bird feeders out of oil. So if you use bird seed and a container, put the oil into it, and then put the bird seed within, work as excellent bird feeders. So that's one option. We've powered vehicles off oil, so off kitchen oil. So in certain areas with high restaurant usage, oil's a problem for us because it creates these massive, you might have seen fatbergs in London with the kind of size of buildings. That's a big problem. But if you cut that off at source, and with education, we used to have people going around collecting in vats the oil, take it into a refinery plant, and turn that into fuel for the vehicle that was collecting the oil. So there's a kind of domestic element to it, but there's waste removal companies if we're talking restaurants, etc. But preferably not down the drain is the thing. But I've been there myself. I've done it when we've used a pan at home and done that prior to working for Yorkshire Water. Should I say?
Well, that's a great set of answers there, because James is going to just chip in, I think.
So ideally what you do if you have a lot of oil is you put it in a container like a plastic bottle and put it in the bin, okay? And then it will go to, in North Yorkshire, it will go to Allerton Park, and there it will get incinerated, so the energy will be recovered that way.
I see, so in the general waste, in a plastic container, in the general waste.
Yeah, with a lid.
With a lid, that's important.
That's the, yeah.
Yeah. At the back, yeah.
Have you ever considered in Japan they got those dewasings? Actually, you can solidify the oil, so they're becoming actually like a rubbish. So they can be like now liquidish.
Oh, I see what you mean. So you actually add something to the oil to solubilize it, so that it just goes down the drain. So, yeah, so it just
No,
acts as
they're not going down the drain. They're going
into
to
the
the rubbish.
Oh, put it into
Yeah,
the
like-
rubbish, so it solidifies
yeah.
and puts into the rubbish. I see what you
Yeah,
mean.
so
Yeah.
you don't deal with like running in your bin bag or
Gotcha.
something like that.
Gotcha. So that's another option to James's, put it in something as a liquid. You're saying we could solidify
Yeah,
it.
because if you put hot oil actually in, plastic bottle, you know what will
Yeah,
happen.
hot oil. I
And
think
when
James
they
meant
actually,
cold.
cool
Yeah.
down,
Yeah.
you still will have something to wash off.
Yeah, no, that's a good point too. Thank you for that. At the back. And then,
Thank you. Now that we are in elections, I would like to know what would each one of you would be asking politicians in terms of policies, in terms of funding, research.
Yeah.
What
So
would be your cards over there?
so we'll go for a quick fire. You're only allowed a quick answer. And Anna, you're going to go last here, so I'm going to give you the chance. Yes. But James is always good with a quick answer. His ask of the next government is
More money for research, I think.
Kieran.
For my role, I'd say more of an impact on the conservation of native species. Completely different to what this is, but the health of the UK is depleting, and I don't think there's much being done about it.
Wow.
Cut.
Cut.
Martin speaking here.
Stop pointing fingers for political point scoring and look at joined up thinking across different sectors.
Anna.
I might ask the politicians for maybe some funding towards more biodiversity and maybe more towards education of the younger generations, because obviously that's the future. And if the children know about the green energy and what to do with the waste, don't call it a waste, it's something that can be used. That probably would be my ask. So towards future generations, please.
And I'd love to have a consistent approach to the approach to net zero, nature positivity and biodiversity friendly solutions. But give us consistency. Don't keep doing this and then down and then up. Keep. We'll only do this with a long-term. It's a long-term game we're playing here, and we have to have a long-term game. And I would love Labour and the Conservatives to actually have an agreed approach that doesn't matter who's in power for this stuff that's going to save the planet, because it's not political. It's actually important for all of us. So that would be my ask, and that would sort of build on what all four of you have said. How are we doing? Oh yes, still plenty of time. We've got a question here. Go on, Kieran.
Really out of my head, sorry, I don't know why it popped in, we're talking about politics. Birds, really wet poo, because you're right. So, ostrich and rhea, I'm not saying any politician to bird brained at all, but that's what popped in. So
This is brilliant. Yes.
So I've got a question about the smell of sewage, because I live in Rawcliffe and I've experienced hot summer days where the wind blows the wrong direction from the sewage plant, and when you open the windows to air your house out, it just gets even worse. It was mentioned that as the population grows and as we get more technology, we're going to be processing more sewage or sewage more efficiently. Is there anything looking into reducing that smell, or is it just going to get worse over time as we do more?
It shouldn't get worse over time. We do look at it. I live in Rockcliffe as well. Not just trading places. We, as part of the efficiency of processes, the smell is gas that's kind of emitted. And obviously, if we want to maximise the use of that gas for energy, we'll actually kind of create the circular economies we're using it. What you've got, I guess, part of the problem with sewerage is that gas creation. Is if you put, let's say, a roof over a plant, that creates quite a difficult environment to manage. But there's kind of two occupational hazards with sewerage works, and that's flies and odour. And as part of our kind of capital programmes, we've always got ongoing works to maintain and improve the asset base to reduce flies and odour kind of across treatment works. And as we condense, I guess, we don't want to grow the footprint of sites because that creates, kind of widens the problem. But what we want to do is make it more efficient and effective. We should reduce odour. James, I don't know if you've got anything to add from a scientific perspective. It was a bit better than that.
I'll be thinking about one last question.
There's all sorts of interesting challenges here. So as you go through anaerobic digestion, you make what are called volatiles. Those are the things that smell. Future-wise, it would be better actually to take those volatiles out than go all the way to gas, because gas is quite cheap and not particularly valuable, whereas if you recover those volatiles earlier, you're actually making more valuable products. So it is, as the efficiency improves, then I think odour will improve as well. And the other thing is to consider the fact that, I mean, some sewage works are right in the middle of towns, and they have to have a lot of odour control, but that will massively push up the price. And I think that's something we haven't sort of talked about at all. Actually, in the UK, you can go to any tap pretty much and drink the water. That's not the case in most countries. And once you flush, you can completely forget about that as a problem. There are very few people that have stories of sewers backing up and suddenly finding their bathroom full to the ceiling. I've seen some of Yorkshire Water's photos. It's horrible, you know. I think you move house in that circumstance. So, you know, water treatment is incredibly cheap in this country, really. And we take that for granted. And probably we shouldn't.
Brilliant. Last yes.
So we spoke about like things blocking the sewage pipes, like wet wipe and stuff. My question was, where does all the sweet corn go?
Yeah.
Glad you came, Martin, with it.
Is anybody having lunch after this? I talked about treatment works before and the kind of primary treatment, and that's often through screens. And the screens will block out the coarser material that won't break down and kind of go into the kind of follow-on stages. Sweet corn is one of those things that our body won't break down, and nor would it, you know, we don't want it in the sewage treatment works. So the filter screens at sewage treatment works filter out the sweet corn. Now, I've seen sweet corn growing from the screened material. So you've got sweet corn plants. I didn't take any home for tea, but they are filtered out at the entry to the works, and then we look at what we do with the byproducts of that.
What a great question, and that's really just summed up this afternoon for me. It's just been brilliant. Thank you ever so much for coming to this and for just being such a great audience and with so many good questions. Would you join me in thanking the four panellists who've entertained us?